For loops are a way to perform a fixed length loop on a block of code. You have the program. The program comes up on the for loop. The for loop will initialize, and then it'll execute the block. After the block, there will be an update. The update will then move back to the top of the block again. The block will run, and this cycle will continue until there's a termination condition that is met. And then when the termination condition is met, the program proceeds as normal again. So let's take a look. Here's the code from that flow diagram. We have for, I equals, and then we have a row vector. We have the block, and then we have end. So initialization, updating, and termination actually falls under the statement I equals row vector. Within each iteration of the loop, I will assume in order a value from row vector. And then the block will just be an arbitrary block of code, and it can be pretty much whatever you want. The number of iterations is actually the number of columns in row vector, and the loop finishes when you reach the end of the row vector and then the end of the block. After the loop, I retains that last value in row vector. So here's an example. We want to compute z equals x to the y for x equals 0.2, 1.1, 4.2, and 5, and y equals 2, 3, and 4. Here's the code to do this. We have x representing the vector of the values. We have y, another vector of the values, and then z is 4 by 3, 4 for each value in x, 3 for each value in y. Z is going to be 4 by 3, where 4 for the 4 values in x, and y for the 3 values in y. And we have I looping from 1 to 3 to represent each column in Z, which is also corresponds to each value in Y. And we go Z of the ith column equals x raised to the y-ith power. The classic usage is like you see here, for I equals 1 to n. We could also have done a different usage where we go for yi equals y, so that yi actually cycles through the values of y.